Drawings and models. Learning objectives. To model three-dimensional objects using isometric, orthographic, and foundational drawings to understand and draw basic nets. In geometry, you will study two-dimensional and three-dimensional figures. Of course, the paper or computer screen on which we study three-dimensional figures is actually 2 dimensions. Therefore, we must come up with ways to represent 3D figures in a 2D manner. In this section, we will explore several of these methods. Let's take a look at some vocabulary. Isometric drawing, a way of representing a three-dimensional figure from a corner view, showing 3 sides with the angles between the 3 axes equal. Isos is Greek for equal, and metron is Greek for measure, also known as an isometric projection. Let's try something a little more challenging with example 1. Use isometric graph paper to copy the figure to the left into an isometric drawing. Pause. Alright, how did you do? What we're going to do for this one is find all the edges of the figure and draw them onto the isometric graph paper. And this just takes a little bit of practice to see it. I'm going to shade it in here so you can see it better. So how many blocks were used to make this figure? What do you think? 6. Don't forget about that hidden one underneath. Okay, so let's take a look at orthographic drawings. An orthographic drawing is a way of showing a three-dimensional object in 2 dimensions by showing a front, top, and right side view of the object. So I'm going to start off with a figure here made in SketchUp. This is the front view. This is the top view. This is the right side view. And I'm going to turn it for the isometric view, the corner view. So I'm going to take this view and explode it so you can see the front side in blue, the top side in red, and the right side in green. So the left is the orthographic drawing, and the right side is the isometric drawing with an exploded view of the sides. And again, you're trying to find the edges and figure out what shapes you can pick out from each view. Example 2. Make an orthographic drawing from the isometric drawing left. Pause. So I'm going to start with the front view, and I'm going to try to imagine what shapes I see. So I see a square with a rectangle on the right side and a rectangle on top of the square. So that's my front view. My top view, I'm going to imagine standing in the front, looking down. So I'm going to see 2 squares on top of each other, and on the right side, a 2x1 rectangle. The right side view, I'm going to see 2 squares, 1x1 squares, with 1 2x1 rectangle going straight up.
As discussed earlier in the video, you can use 3 views to describe the entire object, or use 2 views when the object has symmetry, as you can see here. However, orthographic projections are usually made up of 6 principal views. When drawing orthographic projections, you need to choose which views to present. To pick the right views, you must pick a front view that is the most descriptive. Most common combination views include front, top, and side. Views other than the principal views are called auxiliary views. When drawing orthographic projections, by convention, the views must be aligned as illustrated. You can see that the edge of the front view and the shared edge on the right view are aligned. Additionally, the length of one of the edges on the top view is the same as the shared edge on the right view. Is this orthographic projection drawn correctly? You may want to pause the video here and contemplate this answer. Hopefully you answered that the alignments of the views were off, and therefore this is not a correct way to display orthographic projections. Now that we just completed talking about orthographic projections, let's talk about the line types you'll have to use. Object, hidden, centerline, dimension, and construction lines are the most commonly used lines. Familiarize yourself with these lines, as you will need to use appropriate line types while sketching. Here's an example displaying the various line types. You may want to pause the video here to analyze this example further. You'll encounter situations when you have multiple lines drawn on top of one another. For such situations, you must follow precedence of lines. Visible lines take precedence over all other lines. Hidden lines and cutting plane lines take precedence over center line. Center lines have the lowest precedence. Here is an example of how we apply precedence of lines. You may want to pause the video here to take a look at this example more in detail.